Let's review what we discussed in class today. Confidence intervals are intervals which we believe to likely contain the true population parameter. Each confidence interval has a certain confidence level. If our confidence interval has a 95% confidence level, this means that 95% of all possible samples of the same size will produce intervals that capture the true population parameter. If our confidence interval has a 90% confidence level, this means that 90% of all possible samples of the same size will produce intervals that capture the true population parameter. And finally, if our confidence interval has a 65% confidence level, this means that 65% of all possible samples of the same size will produce intervals that capture the true population parameter. We also know that a critical value is the number of standard deviations from the mean of the sampling distribution, such that the shaded area between the critical values is the same proportion as the confidence level. The symbol for a critical value for estimating a population proportion is z with a little asterisk. Let's find the critical value if you want a 95% confidence level. Before, we used the empirical rule to estimate the critical value of z being 2. Now we want to find a more accurate critical value. Since we're looking for a 95% confidence level, imagine the 95% is shaded between the two critical values. That means that there's 5% left over. Since it's symmetric, we know that each side of the 95% has an equal area, so that means on either side is 0.025. Since the area to the left of the critical value is 0.025, we can look up that area in the z-score table to find the corresponding z-score. Since it's 0.025, we're looking at the negative side of the z-score, and the value that is closest to 0.025 has a z-score of negative 1.96. But our critical value is always going to be positive, so the absolute value is 1.96. So from now on, when we're looking for critical values for a 95% confidence level, we're no longer going to estimate. We're going to use 1.96 as the critical value. Let's find the critical value for 80% confidence level. So this time, imagine that 80% of our distribution is shaded, which leaves 20% or 10% on each side. Since the area to the left of the critical value is 0.1, we're looking up the area in the z-score table to find the corresponding z-score. So, which value is closest to 0.10? 0.1003 is closer than any of those other areas. So, our critical value for this is going to be 1.28. Remember, we're using the absolute value of the critical value. Let's find the critical value for a 90% confidence level. Again, 90% is shaded in between, which leaves 10% left over. So in our tails, we're looking at 0.05. Since the area to the left of the critical value is 0.05, we look up the area in the z-score table and find the corresponding z-score. Which value is closest to 0.05? Well, this one's a little bit tricky because we have two values that are equally distant from 0.05. So what are we going to do? We're going to use the z-score that's in between. So the number that's between negative 1.64 and negative 1.65 is 1.645. Stop here and take a moment to find the critical values for the following confidence levels. When you're done, come back and check.